Number 8 is taken from the Edexcel International A-Level Maths Pure 2 Sample Assessment Material 2018. As we can see in figure 2, we have two curves and they intersect at A and B. This is the first, this is C1, which is the equation of the first curve, and this is the equation of the second curve. Written next to each curve, the equation of it, where x is greater than 0. Part A, verify that the point A has coordinates 1, 1. So we need to prove that A has coordinates 1, 1. So in order to find the coordinates of A, we can substitute the coordinates of A in the first curve and in the second curve, equation of the first curve and equation of the second curve. Then we can prove that if the coordinates satisfy both these two equations, then 1, 1 would be the coordinates of A. So if we substitute in C1 y by 1 and x by 1, which is the coordinates of A, and we evaluate, we are going to get 1 equals 1. Therefore the coordinates of A satisfy C1. We do the same thing for C2. We would get 1 equals 1. Therefore the coordinates of A 1 equals 1, 1 satisfy both equations. Therefore it's these coordinates are the coordinates of A. Use algebra to find the coordinates of the point B. Now, in order to find the coordinates of the point B, and they specified for us to use algebra, it means we have to use the method of y equals y, which is the y of C1 equals to y of C2, and we solve for x. Now, why do we use this? Because we know that because B has coordinates x of B and y of B, and since we have already proven that the coordinates of A satisfy both equations of the curve, therefore we can write x of B equals x of B, where you will have here x, you will write x in terms of y, and here x is already, you can take it as in terms of y, or you can write y of B equals to y of B, which means that y of the first curve is equal to y of the second curve, and you find the coordinates of B, and also you will be finding the coordinates of A also, or proving that the coordinates of A are going to be 1, 1, because y has only one, B has only one y that satisfies both inequality, both curves, equation of the curves, and it has only one x. So the x and the y of B will satisfy both equation of curves C1 and C2. It's the same concept as in part A, how we proved that A has 1, 1 for its coordinates. So y equals y, we can write y equals y in order for us to find the coordinates of B. So in order for us to start solving for x, we have to take everything on one side and equate the equation into 0. We notice that we have a cubic function, therefore in order to solve for x we need to factorize this cubic function, and in order to start factorizing this cubic function we're going to need a factor. Now we already know that x equals 1 is a root of this equation because a has its x, so x of a is 1, and we already proved that it satisfies the two curves. Therefore 1x equals 1 is a root of this equation. Therefore, using synthetic division, we divide to find the rest of the factors. Now synthetic division only uses linear, so this is x minus 1 equals 0, only uses linear factor, the root of the linear factor, so we have a 1 here, and uses the coefficient of each x found in the equation such that you have to keep them in order. So it's x cubed, coefficient is 1, x squared, coefficient is 1, x coefficient is minus 10, and the constant is 8, or the x coefficient of x to the 0 is 8. You should keep the order, and the order is descending order. Then you skip a line and you draw a line. You skip space here and you draw a line, and then you start your process. You put the 1 down, then you multiply by the root, and you put the answer here. Then you add 1 plus 1 is 2. You take the 2, you multiply it with the root, and then you put the answer under the minus 10, and you add, you get minus 8. Then you multiply minus 8 times 1 is minus 8, adding it's 0. This is the remainder. So since we already know that 1 is a root, therefore the remainder should be 0. Therefore we have to write the outcome. This is the outcome that we found, or that we calculated after dividing by x equals 1. So we start writing the quadratic equation, because when you divide x cubed by x to the 1, you're going to get x squared as the first term. So 1 coefficient here is 1 x squared, 2x, minus 8 is the constant. Now this is the outcome, or the value of the division after you have divided it by x equals 1. Now we need to factorize more, or we need to factorize x squared plus 2x minus 8 into linear factors. So using sum and product, we factor x and x, then the minus 8 is factored into minus 2 and 4. Then we check x times plus 4 is plus 4x, minus 2 times x is minus 2x. Adding these two up will give you the sum, which is 2x. So this is right. Our factorization is right. Therefore, if we want to write the factorization, the linear factors of x cubed plus x squared minus 10x plus 8 equals 0, it's going to be this value. So now we have x equals 1 as the first root, x equals 2 as the second root, and x equals minus 4 as the third root. We already have x equals 1, which is the value for the x coordinates of A. Therefore the value for the x coordinate of B is going to be 2. If you look at the figure next to your right, x cannot be minus 4 because B is on this side and it is on the positive side of x. In order to find the y of B, you replace x equals to either in the first equation of C1, curve C1, or in the equation C2. So replacing x equals to n in the equation of y equals x cubed is easier. X cubed is 2 cubed, which is equal to 8. Now we come to part C. In part C, we have used calculus. The finite region R is bounded by C1 and C2. Use calculus to find the exact area of R. Keeping in mind that when they say exact area, it means that you have to keep the outcome as it is without changing it into a decimal form. So integrating, since it's bounded by x1 to 2, if you look at the figure here you have x of a is 1, and we found that x of b is 2, and we need to find the region shaded and region R shaded in here, and the bound is going to be 1 and 2. In order for us to find the area which is the shaded, it's going to be y of the upper part minus y of the lower part. The upper part is y equals 10x minus x squared minus 8, minus the lower part, which is represented by x cubed. So if you look here, it's y of the first or the upper part minus y of the lower. So y of the upper minus y of the lower curve dx. So integrating, we're going to get 10x squared over 2, because you add 1 to the exponent and you divide by the new exponent. Then plus 1 here is going to be x cubed over 3, then 8x over 1, and x to the 4 over 4. Since here we have 10 and 2, we can divide them. Divide by 2 is 1, divide by 2, 10 divided by 2 is 5. And then you start replacing. You replace the 2 first because it's the upper bound. Instead of x, you replace 2. Then you subtract the second lot, which is you replace it by the second bound or the lower bound, which is 1. So you are having these two parts to calculate. You plug them into your calculator and the answer is going to be 11 over 12, and you keep it as it is because they asked for the exact value of this integration.